Everyone, my name is Normas Aina binti MD Buhari from the Software Engineering Department, Faculty of Information and Communication Technology, University Technical Malaysia Melaka, UTM. In the previous lesson, we have learned about the aggregation and grouping operation in relational algebra. Now, we are going to learn about nested queries in relational algebra. To show the nested query techniques in relational algebra, we use the member type, member, and loan entities of this library management system, LMS. In short, the member type table is related to the types of members, staffs, students, or external members outside this organization. Each member type has one or more members, and each member is categorized into one member types only. Of course, each member is allowed to make one or many book loans at one time or no book loans at all, and each book loan is made by one member only. Let's look at examples of data for these three entities. As mentioned, there are three types of members: staff, students, and external members. Each member type has a predetermined numbers of books and the maximum numbers of days for each book loan. For example, each staff may borrow a maximum of 10 books at a time, and each loan expires on the 30th days. You may refer to these tables to see the maximum number of books and the maximum number of loan days for students and external member. Next is related to member data. Each member has a member type ID. Number 1, number 2, or number 3. You may refer to this member type table to find out the member type name for each member type ID. Member type ID number 2 are student. Member type ID number 1 are staff. Member type ID 3, external members. Each book loan contains member ID. This loan with this loan ID is made by member ID 3000, which refers to Sarala Murugan in this member table. Well, let's learn how to get data from these tables using nested query techniques and then construct the statements in relational algebra. Example number 1, obtaining data from two database tables using type 1 nested query techniques with comparison operator equal. The inner query must return a single value. So the query is: construct the SQL and relational algebra statements to display the name of members who are students. This is the expected output of this query with two records. Number 1, Nur Ariana Farha, and then the last one, Muhammad Aryan Zarfan. If you still remember about our member tables, no member type name is specified. Member type name is in the member type table. So this query involves a relationship between two tables, member type and member tables, with a common attribute names or column names, member type ID. Let's look at an SQL statement for this situation. The input specified in the query is the word students, and we know that the word students is in the member type table, not in the member table. First, we need to get the member type ID for students. Then we can find the member names in the member tables based on the related member type ID. As we have learned in Module 14, this statement is known as the inner query. This inner query must have open and close parentheses. This inner query for this situation will produce one value, which is number 2. This value accepted by this comparison operator equal. This comparison operator can accept one input value only from the inner query. Next, we need to know the function of this statement. As we learned in Module 14, this statement is the outer query that receives input from the inner query statement. As mentioned, the input is only one value, which is number 2. This outer query will get the member names from the member tables that has a member type ID number 2. There are 2 students, Nur Ariana Farha and Muhammad Aryan Zafan, with member type ID 2. How do we construct a relational algebra statement for this SQL? Let's look at the next slide. Steps to construct nested queries in relational algebra. Step number 1, we need to include this statement, which is equivalent to select member name in our SQL statement. This is a projection symbol to display one or more columns. But for our query, for the first example, we want to display one column only, which is member name. Step number 2, on the same row or a different row, include the table name, member table name, which is equivalent to from member in our SQL statement. You must include the open and close parentheses. Step number 3, include the query condition. So this one, corresponding to where member type ID equal in our SQL statement. This is a selection symbol to represent our condition. Then we need to include the letter A with open and close parentheses to represent our inner query. You may include any letter other than A. Next, we need to include the open and close parentheses to complete the outer query statement. Step number 4, we need to insert the inner query statement. Enter this statement, letter A, colon, projection symbol, and followed by member type ID. This statement corresponds to select member type ID in our SQL statement. This member type ID is from our member type table. Same with our member tables, we need to insert the open and close parentheses. Then we need to insert the query conditions. This is equivalent to our SQL statement where member type name equal student. And the last one, we need to enter the open and close parentheses to complete the inner query statements of our relational algebra. Alright, next, the second types of nested query techniques, which is in operator. As we have learned in Module 14, this operator can accept more than one value from the inner query. In other words, the inner query can return many values. So the query of this second example, we need to construct the SQL and relational algebra statements to find those loans made by Sarah Morgan, and Muhammad Aryan Firas. Sarala Murugan has this member ID 3000, and then this member ID 1015 belongs to Muhammad Aryan Firas. If we still remember, in our loan table, no member name is specified. Member name is in the member table. So this query involves a relationship between two tables, member and loan tables, with a common attribute or column names, member ID. Let's look at an SQL statement for this situation. First, we need to get the member ID of these two members, Sarala Murugan and Muhammad Aryan Firas. Then we can find the associated loan details in the loan tables based on the related member ID. As we have learned in Module 14, this statement is known as the inner query. This inner query must have open and close parentheses. This inner query for this situation or for our second examples of nested query techniques will produce two values, which are 3000 for Sarala Murugan and 1015 for Muhammad Aryan Firas. So these values accepted by this in operator. As we know, this comparison operator, in operator, can accept one or many values from the inner query. We are not allowed to use comparison operator equal for this example because equal operator can receive one value only. Next, we need to know the functions of this statement. As we learned in example number 1, this statement is the outer query that receives input from the inner query. This outer query will get the loan details from the loan tables that has member ID 3000 and 1015. Alright, this is the relational algebra statement for our second query, example number 2. The same steps as the previous example, example number 1. So this statement, this one, is for the outer query to obtain data from loan table. And this is for the inner query to get data from member table. This is in operator symbol in our relational algebra that can accept multiple values from the inner queries. Example number 3. To get data from 3 database tables. The query. Construct the SQL and relational algebra statements to list those loans made by staff and external members. These are the expected output of this query. Member ID 3000 belongs to Sarala Murugan and member ID 1015 belongs to Muhammad Aryan Firas. If you still remember in our loan table, no member type name is specified. Member type name is in the member type table, but cannot have a direct relationship between loan and member type. We need a member tables between these two tables. So let's look at an SQL statement for this situation. First, we need to get the member type ID of these two member type names, staff and external member. Then we can find the associated member ID in the member table based on the related member type ID. As we have learned in Module 14, this statement, this one, known as the inner query. This inner query must have open and close parentheses. This inner query for this situation will produce two values, which are member type ID 1 and member type ID 2. Member type ID 1 is for staff and member type ID 3 is for external member. These values, number 1 and number 2, accepted by this in operator. As we know, the comparison operator in can accept one or many values from the inner query. Again, we cannot use comparison operator equal because this operator can accept one value only. Next, we need to know the function of this statement. This statement is the outer query that receives input from this inner query. This outer query will get the member ID. We get the member ID from the member table with member type ID 1 and member type ID 3. This outer query for this situation will produce three values, which are 1014, 1015, and 3000. Member ID 1014 and 1015 are staff. Member ID 3000 is an external member. We need to include open and close parentheses for this outer query. Next, this statement. This outer query will get the loan details from the loan tables that has member ID 1015 and 3000. This is the relational algebra statement for the previous SQL statement. Example number 3. So we need to include three statements to get data from loan tables. So this one to get data from member table, and this one for to get data from member types tables. So we need to include the projection symbol. For this situation, for the third example, we want to get data from our loan table consists of more than one column. And then this is the conditions, right? For loan table, we want to get the member ID from our loan table. And then this is in operator symbol to receive or to accept value from this inner query. So we have this one also. Again, the projection symbol to get the member ID from member table with this condition. And then the projection symbol for the inner query to get the column name from member type tables, which is member type ID, and then with the related condition, member type name equals staff or member type name equal external. Alhamdulillah, hopefully we are able to construct nested queries in relational algebra. You may refer to the reference used for this lesson